Adding and subtracting polynomials. If you look at the word polynomial, poly means many, and nomial is number. It literally means many numbers. You've already worked with polynomials. X plus 1 is a polynomial. 3x plus 2 is a polynomial. Polynomials when I combine variables and numbers with operations. Often we have powers mixed in there. You see some below. 3x cubed y squared, 4x to the 7th plus 6x to the 4th minus 3x plus 1. Those are polynomials. Degree is the sum of the exponents of the variables in a single term. When I look at 3x cubed y squared, it has degree 5 because the variables, I add up the exponents on the variables, and 3 and 2 makes 5. The constant 3, called the coefficient there because it's in front, we don't include it. A constant has degree 0. Look at the next one. 4x to the 7th plus 6x to the 4th minus 3x plus 1. In this case, the degree of the polynomial is the degree of the highest term. If you look at the previous one, 3x cubed y squared, that was one term. And in one term, we sum the exponents. But when we have multiple terms, we don't sum the exponents. We take the degree of the highest term. Now remember, terms are separated by addition and subtraction. This term has degree 7, the second one degree 4, the third one has degree 1. There'd be a power of 1 there if I wanted to put one. And the constant has degree 0. The highest degree term is 7. Doesn't matter what order you put it in, the degree of this polynomial would be 7 because the highest degree term is 7. Do not sum the exponents when you have addition and subtraction between them because those are different terms. We only sum the exponents in a single term if there are multiple variables. But when I have a polynomial with many terms, the degree of the polynomial is the degree of the highest term. We'll talk more about that later. Standard form of a polynomial is when I write it in highest degree down. If I look at this polynomial and I want to put it in standard form, the highest degree term is 4. I would put negative 7x to the 4th first. The next highest degree term is 2. That would be plus 6x squared. And as I said earlier, the constant has degree 0. It would go at the end. This one is in standard form. By the way, this polynomial would have degree 4 because the highest degree term is 4. When I put a polynomial in standard form, the leading coefficient is the coefficient of the first term in the polynomial. In this case, the leading coefficient is negative 7. Leading means in front, but remember that's only when it's in standard form. We classify polynomials by the number of terms and the degree. Remember that terms are separated by addition and subtraction. If I have a single term, that is a monomial, one term. A binomial would be 2 terms. Trinomial would be 3 terms. When we have 4 or more, we just call it a polynomial, meaning many numbers. The degree, remember the degree is the sum of the exponents in a single term. And if I have multiple terms, the degree of the polynomial is the highest degreed term. If the degree is 1, we call it a linear polynomial. If the degree is 2, it's a quadratic. Quadratic makes a shape called a parabola when you graph it. Degree 3 is a cubic. Degree 4 is a quartic. Think 4 quarts in a gallon. And degree 5 is quintic. And there are other names, but these are the only ones I'm requiring that you know. If we look at this polynomial below, 3x squared plus x, and I wanted to name that, that would be a quadratic because the highest power is 2. It's a quadratic binomial because it has two terms. 1, 2, separated by addition. The next one would be a cubic because the highest degree is 3, so it's a cubic. And it has 1, 2, 3 terms. That would be a cubic trinomial. And the last one, the highest degree is 4. It would be a quartic. And because it has 1, 2, 3, 4 terms, we just call it a quartic polynomial. Today we're going to focus on adding and subtracting polynomials. And there's two things you need to remember. When you add and subtract polynomials, add the coefficients on like terms. Like terms means they have to have exactly the same variables and the same power. And the numbers in front are what I'm going to add and subtract. And remember, the powers never change. Why is that? The reason we can add polynomials goes back to the relationship between addition and multiplication. When I write 7 plus 7, yes, that's 14, but I can also write it as 2 times 7. This is why I can write x plus x and rewrite it as 2 times x. That's exactly the same situation. If I ask you to add x cubed plus x cubed, I'll get a lot of students that want to make that x to the 6, but that is wrong. Notice above that when I add 7 and 7, there are two 7s. The 7 didn't change, it's still a 7. And x plus x became 2x's, the x didn't change, it's still an x. X cubed and x cubed, the x cube's not going to change, it's still going to be an x cubed, but I have two of them. Don't make that x to the 6. The powers never change. If I ask you to add x to the 5th and x to the 4th, you're going to tell me that you can't do that because they're not like terms. This would be your answer. There's nothing you can do with that. 7x to the 10th minus 3x to the 10th. Those are like terms. They have exactly the same variable and power. 7 minus 3 is 4. There are 4 x to the 10ths left after I take away 3 of them from 7. 8x to the 5th plus 4x to the 5th. There are 8 of them and there are 4 of them. There's still x to the 5th, but now I have 12 of them. Take a look at the example problem here. Notice the parentheses. It's common to put parentheses around parts of a polynomial if they represent some quantity. What you have to decide is there anything to distribute? There's no number in front here, and there could be a 1 here if you want, and you could distribute positive 1, but that wouldn't do anything. What I'm telling you here is that the parentheses don't do anything. In this situation, then, we can just ignore the parentheses and treat the problem like there were no parentheses at all. What I'm going to do is add like terms. 3x to the 7th plus negative 7x to the 7th is negative 4x to the 7th. Negative 4x cubed minus 2x cubed. Negative 4 plus negative 2 is negative 6x cubed. If I had that same exact problem, except I was subtracting, this subtraction affects everything in the parentheses. That stuff is grouped. And what it's like is distributing negative 1. Negative 1 times negative 7x to the 7th would make it positive 7x to the 7th. And negative 1 times negative 2x cubed would make it positive 2x cubed. Whenever there's a minus, you have to distribute that negative through the parentheses. And what it does is change the signs. Notice this first parenthesis has nothing in front to distribute. Again, you could put a positive 1 there, but 1 times anything is itself. 1 has no effect. We'll drop the parentheses on the first two terms, 3x to the 7th minus 4x cubed, and distribute the negative, which will change the signs of everything in the parentheses. Plus 7x to the 7th plus 2x cubed. Now I'm going to combine like terms. Positive 3x to the 7th and positive 7x to the 7th make 10x to the 7th. Negative 4x cubed plus 2x cubed. Negative 4 plus 2 is positive 2x cubed. And there's my answer. I want to mention here that a lot of students mess up on this last example. And the reason they mess up is they don't show this step. You need to show the step that when you distribute a minus, the signs change. If you're doing that in your head, you're going to make silly mistakes. Please write it down and check your work before you enter your answer in WAMAP. The rest of this video is questions from your assignment. If you have a question as you go through the WAMAP, please go back to this video and fast forward to the right location and find an example that you're looking for. Question 1. Write the equation in standard form and answer the following questions. Standard form is highest degree down. The highest degree term is 5. First, we'd write 10x to the 5th. The next one would be 4 plus, it's positive, 8x to the 4th. Then 3 plus 6x cubed. Then we have a degree 1 plus 2x. And lastly, we have our constant, which has degree 0. The leading term then is this. The whole thing is the term, 10x to the 5th. The leading coefficient is the 10, the number in front when you write it in standard form. And the degree of this polynomial, when you have multiple terms, the degree is the highest degree term. In this case, it's 5. On question 3, we're adding two terms together, and they are like terms. They both have the same power and the same variable. You need to remember the two things I mentioned in the teaching, and that is when you add like terms, you add the coefficients on like terms, and the powers never change. You have to get these memorized because when we multiply polynomials, the powers will change, and we'll have a power on a power. The powers will change there too. It's only when you add, the powers never change. Add the coefficients on like terms. There's nothing in front of that y squared, which means there's a 1. Negative 2 plus 1 is negative 1. You could enter this then as negative 1 y squared, but we don't need to put the negative 1. We could simply write that as just negative y squared, and that would be good too. Question 5. Here we're subtracting, but just think of this as negative 6 plus negative 2. That would be negative 8. They're like terms, so I keep my power. The powers never change when you add. Negative 8a to the 5th. Another subtraction problem. This time I'm going to have negative 3 plus negative 9, or negative 3 minus 9. Either way, it's negative 12. The powers never change when you add and subtract. Negative 12 r to the 4th. Here we're adding two binomials. There's no number in front of those parentheses, but you could put a 1 if you want. You'd be distributing positive 1, which wouldn't do anything at all. In other words, these parentheses are just grouping. They don't do anything other than group. We can ignore the parentheses and just add like terms. My question then is 28 to the 4th plus 6a to the 6th plus negative 15a to the 6th. I could also write that as minus 15a to the 6th minus 35a to the 4th. I'm going to combine like terms. I'm going to start with my a to the 6th, my highest power. That would be standard form, highest power down. 6 plus negative 15 is negative 9a to the 6th. And then I'll add my a to the 4th. They're like terms. 20 plus negative 35 would be negative 15a to the 4th. And there's my answer in standard form. This is pretty much the same as the previous question, except we have trinomials. We're adding two trinomials. Again, we're adding. It's only when you're subtracting that you have an issue where you have to distribute. I could put a 1 in front and distribute positive 1. That wouldn't do anything. I'm just going to add like terms and ignore the parentheses. Negative 10x to the 4th and negative 7x to the 4th. When I add those, make negative 17x to the 4th. Powers don't change when you add and subtract. Negative 7x cubed and positive 9x cubed make positive 2x cubed. Then I have this 3x here that I can't add to anything. There are no like terms that can be combined with the 3x. And I have this positive 10, and there's no other numbers, no constants, we'd call them, that I can combine with the 10. So that will go at the end. This is in standard form, and this would be your answer. Question 14. We're to combine these two polynomials. We're not actually adding, we're subtracting. I fixed that in the code. We're going to distribute that negative, and that will change the signs in the second set of parentheses. Again, it's like distributing negative 1. Negative 1 times negative 4 would be positive 4x cubed, and negative 1 times positive 6 would be negative 6x to the 4th. But remember that when you distribute a minus, it's just going to change the signs. We'll combine like terms. Highest power first. Positive 4x to the 4th minus 6x to the 4th is negative 2x to the 4th. Positive 1x cubed, there's a 1 there, and positive 4x cubed make positive 5x cubed. And there's my answer. This problem is, again, very much like the last one. We're subtracting. It's just that we have two trinomials here. In the first set of parentheses, they're not doing anything but grouping. You could put a positive 1 in front and distribute it, but nothing would happen. It would be 2a squared plus 6a minus 1. Distribute that minus, that'll change all the signs. Negative 7a squared, negative 8a, and positive 7. We'll combine like terms. 2a squared and negative 7a squared will make negative 5a squared. Positive 6a and negative 8a combine to make negative 2a. Negative 1 and positive 7 combine to make positive 6. And there's the answer for question 17. This last question has three sets of binomials that we're adding and subtracting. When I'm adding, those parentheses don't do anything. I could distribute positive 1, nothing would happen. X squared plus 3x plus 2 minus 4x. And then I'll distribute the minus. Positive 9x squared. Negative 1 times negative 9 makes positive 9x squared. And negative 1 times positive 8 makes negative 8. X squared and 9x squared, those are like terms. There's one of them here and 9 there. That makes 10x squareds. Positive 3x and negative 4x make negative 1x. And I don't need to put the 1. Positive 2 and negative 8 combine together to make negative 6.